Good afternoon, everyone. This is BremSter, and today I'm going to try a new Quattroquadri. This is called Quattroquadri Circles by EPH. Yeah, these puzzles have been really melting my brain, but I've really been enjoying them. I don't know how I've done in these, and I'm a little bit, I'm often scared of these puzzles because there's some weird logic, and every time I get to one of these, it's like, does this work the way I expect? I'm never sure. So we'll have to see how this goes. So what do we have in this puzzle? We have standard Quattroquadri rules apply. So each 3x3 box must contain all of the digits from 1 to 9, and digits cannot repeat in a row or column. This is the easiest way I've seen to basically explain the Quattroquadri. I've seen people turn around and say, oh, there must be 1 to 9 and then a subset of 1 to 9. No, just each box contains the digits 1 to 9. Digits cannot repeat in a row. Digits cannot repeat in a column. That's it. Arrows. Digits on an arrow must sum to the value in the attached bulb. Counting circles. A digit in a blue circle. I possibly would have used a different shape for this, but that's me. A digit in a blue circle, because if you're colorblind or anything, you couldn't tell. So these are the blue circles. Basically, any circle not attached to the end of an arrow is a blue circle. Digit in a blue circle says how many times that digit appears in blue circles throughout the grid. So if there was a 5 or if there was a 5 in a blue circle, there would need to be 5 5s in blue circles. If there's a 3 in a blue circle, there needs to be 3 3s in blue circles. XV. Digits separated by a V sum to 5. Digits separated by an X sum to 10. All X's and V's are given. Right. So we may not have, these two digits may not sum to 5. These two digits may not sum to 10. Okay. I'm going to restart the puzzle to restart my timer. Let's give this a shot. Now, I know I should start by looking at the counting circles, but I'm going to start with the arrows. The minimum I can put into a 3-cell arrow is 1, 2, 3, which would make this 6, 7, 8, or 9, because the minimum 1, 2, 3 adds to is 6. So this is 6, 7, 8, 9. This is 6, 7, 8, 9. Now, that's not enough to go off. I need to look at the counting circles. How many do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the maximum digit I can put into one of these counting circles surely is a 4, because I can't put more than 4 of the same digit into a grid. Because and the way I like to think about counting circles is they're basically like a grid-wide killer cage, because so these are 1, 2, 3, and 4, because I cannot put 5 of the same digit into the grid, because I've got 1 of each digit in here, 1 of each digit in here, 1 of each digit in here, and 1 of each digit in here. So the maximum digit I can put into a circle is 4, because if I put 5 into a circle, I could put a 5 in here, 1 5 in here, 1 5 in here, and 1 5 in here, and that's it. I couldn't put a 5th 5 in, but I'd need to if I put a 5 in a circle. So the maximum digit I can put in to a circle is 4, and there'd be 4 4s. But then I can't put any more 4s. And then I could add 3 3s, 2 2s, and 1 1. 4 plus 3 plus 2 plus 1 is 10. So these are 1, 2, 3, and 4. 1, 2, 3, and 4. Now, these can't sum to 5. These can't sum to 5. Only one of these. There must be 4 4s in the grid. So there must be a 4 in each of the... I'm going to highlight these to make them more visible to myself. And so I can uncolor them when I get there. So these are 1, 2, 3, and 4. There must be a 4 in one of those two. There must be a 4 in one of those two. There's only 1 1, but there must be a 4 in one of these two. So there's no 1 there because there's no V there. There must be another digit from 1, 2, 3, or 4 on that arrow. Actually, forget about highlighting the circles. I think I need to highlight high-low. Because, maybe not. Yeah, there must be another digit from 1, 2, 3, 4. Because if there wasn't another digit from 1, 2, 3, 4 on this arrow, then if there wasn't another digit from 1, 2, 3, 4 on this arrow, then this would be 156. And the minimum it could be, it'd be 156, and this would have to sum to 11. So there must be another blue digit in here. So, and then but there can only be one more. So this can't be 2, 3, 4. There must be a 1 on this arrow. So there's no 1 here, and there's no 1 in either of these. Now, there must be a 1 on the arrow. It doesn't mean it's in the circle, though. But I can't make this 2, 3, 4 because then I'd need too many low digits. Now, if this was 1, 2, 6, these would be 3, 4. That would be fine. I can't make this 1, 2, 4 because then these would both be 3. This can't be 7. There must be a 5 or a 6 in here, because I can only use 2 of the digits from 1, 2, 3, or 4. So there is a 5 or a 6. This can't be 6. So there must be a 5 or a 6 somewhere on this arrow. If it's a 6, it's with 1, 2. I can't use a 4, because as soon as I use a 4 with a 5 or a 6, I'm broken. There's no 4 here. There's a 4 in one of these two. So it's either 1, 2, 6 or 1, 3, 5 or 1, 2, 5. But no but. Oh, these are from 1, 2, 3, 4. So these are low. There's no 4 there, so there's no 1 there. There must be a low in here. This arrow is the same, isn't it? There must be a low digit on... That's a low digit. There must be another low digit on this arrow, because otherwise it sums to too much. So, and I can't put a low digit here. I've got all the low digits. These are all high digits. And these are all high digits. So this is a high digit. This is a 5 or a 6. This can't be 6 or 7. And this is another low digit, which is 1, 2, 3, or 4. Now, these can't sum to 5 for multiple reasons. Because if these sum to 5, this would have to sum to 10. There's a low digit on here. These are all high digits, because if there was no low digit on here, the minimum these could be would be 5 and 6, and they sum to 11, not 10. And I can't put a 5 onto this because it'd be 2 5s. Each X clue must be a low digit plus a high digit. Still not sure how I'm supposed to figure this out. I need to put 4 4s into circles. I can only put 1 1 into circles. There's no 1 down here. There must be a 1 on here, but it doesn't necessarily have to be in the circle. There is a 1 on a circle in that box. There must be a 1 on a circle in this box, because these are the low digits and they're all on circles. There's no 1 here. So there's a 1 in one of these two. So I can't put a 1 here. Now there's only 2 2s in circles. I need a 4 in circles in every box. There's no 4 here. There's no 4 here, because if this is a 4, there's no 4 on circles in this box. There's no 4 here, so there's no 1 here. This is a 2 3 pair. There's no 2 3 here. Now there must be a 1 on this arrow. If this is 1 4, if this is a 4, this can't be a 4. I can't put a 4 on this arrow, the same as I can't put a 4 on this arrow. This is a 4, the minimum here is 9. This is the 1, and that's the 1 in the arrow. There's no 1 here. There's no 1 in any of these. This is 2 3 4. Now I've got... This can't be 2 3. Of course, there must be a 4 in here, but whichever one the 4 goes with is fine. So these sum to 7 or 8. This is a 2 3. If this is a 3, this has to be the 4. If this is the 3, this couldn't be a 3 or a 2, because that would make either the same digit or a 5. If this is a 2, this couldn't be a 3 or a 2 because it'd be the same digit or a 5. Whichever one this is the 4. There's no 4 here. I need to put a 4 in a circle in each box. There's no 4 here. This can't be the 1. It's now next to the 4. That's the 1, which is the other low digit. There must be a low digit on here. This must be a 1, 9, and the 1 up here is telling me this is the 1 and this is the 9. This is the 5 or the 6, which we know is a high digit. That puts 9 in one of those two. This is a high digit. That's fine. I don't know that I need a low digit in this box. But there is... Oh, no. Circles, circles, circles. I must put 3 3s into circles. There is definitely a 2 and a 3 in here. So one of these is 2. Let's colour the 2s. I'm going to get rid of the high-low colouring now. I think it's done its job. Because what I want to do is say, if this is a 2, this is a 3, this is a 2, this is a 3, this is a 2. So there would be a 3 in here. This would be 3, 4. Sorry, this would be 3, 4. And that gives me 2 of each colour. And this would need to contain... Right. Whatever this is the opposite. This is the same as that. This is the opposite. This is the same as blue, and yellow must be in here. So now I've got 2 of each of the colours in circles already. Because this must be the opposite of blue. This must be the opposite of yellow. This must be the opposite of blue. This must be the opposite of that one. So the 2 or the 3 that goes in here is this is the opposite. These must be the same, and these must be the same. The one that goes in here must be the 3. This is a 3, 4. This is a 2, which doesn't help me because that could still go with 5 or 6. This is a 3, 4, but that doesn't tell me which one is which. Yes, it does. That's a 4 because this can't sum to 5. That's a 4, that's a 3. These, I need to put a 5 in here. That's no problem. 6 can't go next to 4. Let's put the quadruple in. 5, 6, 7, and 8. 8 can't go next to 2. 6 can't go next to 4. 7 can't go next to 3. And we get to that. It doesn't seem particularly useful, does it? One, 2, 3, 4, 5, 6, 7, 8, 9 goes into there. That's not a 6. That's not a 9. I'm quite stumped. I am quite stumped. So this is between 2 and 3. Now, so this can't be 1, 2, 3, 4. It could be 5. It could be 6. It can't be 7 or 8. It could be 9. It can't be 7 or 8 because it would form an X with one of those two. But I don't have that anywhere else. So 8 is in one of these. 7 is in one of these. If 7 is in one of these, it's going to distinguish which one of these is true. But like 7 is in one of these two. But 1 is in one of those. 1 can't go next to 4. 1 can't be here, 1 can't be here, 1 can't go next to 4. That is the one in the box. So 9 can't go in any of those. 9 is in one of those two. 6 is not in any of those. 6 is in one of those two. But 5, 7, and 8 are not restricted. Oh, it's right here. That 4 can't go next to a 6. That's a 5. That's been there how long? But again, this is 6, which means this is 2 or 3. It doesn't actually narrow anything down. It makes this the 6, though, which takes 6 out of those. This can't be a 5 either. That's a 7 or an 8, which does tie up to this. 5 is in one of those two, so there's no 5 here. This isn't a 6 because it would tie to... Right, where's 6? 6 can't go in either of those. 6 isn't in any of those cells, and 6 can't go next to 4. That is the 6. Right? There's no 6 in either of those. So the 6 in this box now, that can't be a 6, it's next to 4. These can't be 6. This is the 6. 1, 2, 6 makes this a 9. Taking 9 out of those. That's a 5, 7, 8 triple. So 7 is in one of those two and not there. So these can't be 1, 2, 3, 4, 5, 6, 7, or 8 are the only digits that can go in here. They can't be 1, they can't be 2, 3, they can't be 4, 5, 6, 7, 8, can't be 9. They are only from 6, 7, 8. That can't be a 6. Right, these are 1, 2, 3, 4, 5. This is 6, 7, 8, 9, can't be a 6. If this is 8, these become, yeah, if this is 8, this becomes 3, these become 2, and that works. If this is 9, This becomes 3. This becomes 2. These are 3. These are 3, 4. This is 2. 8 would go there. I'm not seeing anything obviously wrong with that. Oh, I've got number of circles. There's a 3 here. There are 4 4s in circles. 1, 2, 3, 4. And then there's the 3 here. And then once... Hang on a minute. Yeah, there's 1 of each there and there's 1 of each there. So that will get me my total. Whichever way blue and yellow resolves is going to give me 3 3s, 4 4s, 1 1 and 2 2s. So it's not the circles. It's got to be XV, doesn't it? But I'm sorry, I am completely blind, everyone. This 3 says that's not a 3. But this one could still be a 3. These are 5, 7, 8, 9. That can't be a 9. That can't be a 9. So this is 5, 7, 8. Uh, the only way I can see to resolve this is say, if this is this and this is this, what happens to the whole grid? If this is 3 and this is 9, what happens to the whole grid? Because if this is 3, this becomes 2, this becomes 8, this becomes 9, 5, 7, 3. I can't follow it. If this is 3, this is 8. So hang on, if this is 2, this is 3. So this is the opposite of this. So this is the yellow high digit. So the blue high digit is down here. This... If this is an 8, this would be a 7, and that could be neither 2 or 3. This has to be a 5. This becomes a 7-8 pair, making that a 5, making this a 7-8 pair. Which is the blue 7-8. This is the yellow 7-8 because it can't be next to blue. This is the blue 7-8. That was something, wasn't it? There's no... 5 there. So this is the yellow 7, 8. This is the blue 7, 8. This has to be yellow because it can't be next to blue. I'm basically saying that whatever these would be, they the blue and the blue sum to 10. And the yellow sum to 10, so they can't be next to each other. So there's a blue 7, 8 in here somewhere. It's not there. That's right, that's not 7 or 8. That's 5 or 9. So the blue, well, this can't, if this was an 8, this would be a 7, and that would have no fill. This is a 9, yellow becomes 3. That's tricky. So yellow is 3 and 7 and 7 and 7. Yellow is 3 and 4. Blue is 2 and 8. 8, 2, 8. There's no 8 in either of those. This is a 2. I've done all the coloured cells now. This is the 5. This is the 8. That makes this the 9, which makes this the 6, and that the 7. That was tricky. I wonder if there was another way through that. It was beautiful logic, but boy, did I find that tricky. I'd be really curious in the comments below if there was another way through that I missed. That was really tricky, but I really enjoyed it. Trying to figure out how those 2 3s would bounce off each other. I mean, the opening was fairly obvious with the 1, 2, 3, 4s, and then doing some high-low logic, and then having to switch to which ones could be next to each other and which ones couldn't. And then the fact that you couldn't have a 7 and an 8 or anything next to a 2, 3 pair was just really cool. I just had to figure that out. That was really nice. That was cool. Well, I got to the correct solution, so obviously I solved it. Thanks everyone for watching. I hope you enjoyed that one. I really did. And as always, good luck with your solving.